This video on solving inequalities will look at absolute value inequalities. So here we have our problem, but before I even want to start the problem, I want to talk about what an absolute value inequality means. Let's say we have the absolute value of x is less than 7. What does this actually mean? Well, when we talked about absolute value before, we talked about it being the distance from 0. So if you think about graphing this, my distance from 0 has to be less than 7. So if here is 0 and I put 7 here, this distance is less than 7, but also negative 7 has a distance. So anything in what I marked here has a value from 0 that is less than 7. So if you listen to my words, visually, we're saying our value could be between negative 7 and 7. Notice I'm emphasizing the word and. So anytime we have a less than inequality, and that means you have isolated your absolute value to one side and you have a less than symbol, you are going to use the word and between both equations. Now this is slightly different than if we have absolute value is greater than 7. What do I mean by greater than 7? Well, that means the distance from 0 is more than 7. So that really means we need to be more than 7, or if I come down here to my negative values, this is also more than 7 away from 0. So if, listen to my words again, we're talking about that shaded region, we can be either here or ding, 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 here, which means whenever we have a greater than absolute value problem and we write our two statements, we're going to use the word or. So let's go ahead and look at the problem we have to the left here. And I'm going to go all the way back to using our steps when we were just solving an absolute value equation. Remember those steps? The first step, does anyone remember what it is? It is to isolate the absolute value. That means if we come back to our problem here, we are going to first add 3 and add 3 to both sides. This is going to give us 2 absolute value of 6 minus m less than 10. Our next step would be to divide by 2. And again, I'm dividing by a positive number, so it's not going to affect the less than symbol. And this will give me the absolute value of 6 minus m is less than 5. Now we have isolated the absolute value. Our second step is to write two equations. One, we're going to call the positive one, and I wrote same here, which means we're going to keep the same number value and the same sign, like inequality sign, and then we're going to also do the negative, and in that case we're going to negate everything and also flip the sign. But the new thing we're going to add is if it is a less than symbol, you are going to use the words and between your two statements. And if it's a greater than sign, you're going to use the word or. So right here we have a less than sign, so we're going to use the word and. So that means I'm going to write the positive statement, 6 minus m, keep my sign the same and keep my value the same. I'm going to use the word and because it's a less than. Remember, think less than, the number has to be less than a value on either side of 0. So we're going to use the word and. And then I'm going to make a 6 minus m, flip the sign, and make everything on the other side negative. And then our third step is to solve each inequality and then to think about the and or situation at the end. So what does that mean? If I solve the left side, I'm going to get negative m is less than negative 1. I'm going to divide or multiply by a negative 1, which will change the sign. Over here, I'm going to get negative m is greater than negative 11, and the same thing, I'm going to multiply by a negative 1, change sign here. Now, if we think about this needs to be an and situation, what does that mean? Well, if I were to graph these, the left side is saying that m needs to be greater than 1. The right side is saying that m has to be less than 11, and we want an and situation, so our answer really will be this part, the overlap in here. So our solution will be that m is between 1 and 11, or in interval notation 1 comma 11 with parentheses. So remember, to isolate the absolute value, you're going to write two equations just like we did before, but this time you need to think about same and keeping the sign the same, negative and flipping the inequality sign, and then whether your overall statement, once you have isolated it, is a less than will be an and a greater than is an or. If you're having trouble with this, I'm going to show you a different way you could approach these problems on the next slide. So if you're having trouble remembering that a overall less than is an and a greater than is an or, here is another way to approach the problem. So here's the exact same problem, and I've done everything we did on the last slide in terms of isolating the absolute value. Now, instead, a different way to approach this is go ahead and solve this with an equal sign. Remember how we solved it before? You're just going to do 6 minus m equals 5. 6 minus m is equal to the opposite. Go ahead and solve these, so we'll get m is equal to 1. And remember from the other slide, m is equal to 11. Now, to figure out where we're shading, actually go ahead and graph both of your values where it was equal to. And since it's a less than, and let me circle it and not underline it, I'm going to put an open circle at 1 and an open circle at 11. And here you are going to test around all of your zeros. So we have two places where we have values or zeros, or actually when we get to the next video, we're going to call them cut points. We want to test around them. So if I'm talking something to the left of 1, it would be like 0. If I plug 0 into, you could go up to the original statement, or I'm actually going to go even, right here and look at this statement. The absolute value of 6 minus m is less than 5. If I plug 0 into this, I'm going to have 6 minus 0, absolute value is less than 5. 6 is less than 5. Does that make a true statement? No, it does not. So that means I am not going to include this area. How about between 1 and 11? A number you could use would be maybe 2 or 3 or 4. If I do the same thing and do the absolute value of 6 minus 2 is less than 5, does this make a true statement? This is going to give me 4 is less than 5. Yay! That's a true statement. So this means that will be part of our answer. And then finally, if I test something greater than 11, like 12, I will get the absolute value of 6 minus 12 is less than 5. Does that make a true statement? This is going to give me the absolute value of negative 6 is less than 5. 6 is less than 5. Wah, wah. That's not going to give us a true statement. So when we look at where we have gotten true answers, our answer will be 1 less than m less than 11, or 1 to 11, just like we did on the previous page. So this is another way you can approach the problem if you're having trouble with the and the or. I solved with just an equal sign, and then I tested around my zeros or cut points I used the more simplified version. You could also have plugged it into this and tested to see whether or not it made a true statement. The only thing I would remember to do is this was just a less than. If it were a less than or equal to, down here I would make these solid points instead of open circles, and then I would include brackets in my final answer. So just another method. And either method is acceptable to use for solving absolute value inequalities. And let me emphasize one more time, if you are using that less than means and, this is only once you have isolated the absolute value signs. So for example, you may think, oh, this is an and situation because it's a less than, but you haven't isolated it yet. If I isolate this and I move that, subtract -2, I'll get -3 minus x, absolute value, is less than -6. Now to isolate, I need to divide by a negative or multiply by a negative, and that is going to flip the sign and change the sign. So now I have isolated my absolute value, and my overall problem actually is an or situation. So be careful of your and ors when you're doing inequalities, or go ahead and try a new method for solving absolute value inequalities.